Hello and welcome to the Module 4 Post-Lab Reflection, where this week we created aqueous solutions of calcium chloride and sodium carbonate in order to make a precipitation reaction. Within this lab, we used filtration methods to get a product from the reaction of calcium carbonate. As previously mentioned, I will be facilitating a double displacement reaction in this lab using filtration methods. We will be working with sodium carbonate and calcium chloride. Both of these substances can be irritants, so I am wearing protective gloves and protective lab gear as well as safety goggles. For spill measures, I have paper towels and a regular towel. Now, there's no ecological significance to sodium carbonate. However, the SDS sheet does state that if there is a spillage, that it should be put in a sealed container pending waste disposal evaluation. And I do have the spilled container here. For calcium chloride, the SDS states that it should not go into the wastewater system. So pending any spill with the calcium chloride, it will be gathered up and put either in this container or in a separate bag in order to be put into disposal. The procedure for the lab will involve two separate mixtures of the sodium carbonate and calcium chloride with distilled water, and then afterwards mixing the two to allow a reaction. We will then use gravity filtration to separate the precipitant from the supernatant. The supernatant can be flushed down the sewage system, so it will be flushed down and then the sewage drainage system will be flushed for about 10 seconds. The precipitant will then be allowed to dry overnight. It will have a label so that since it is not going to be supervised 100% of the time, and then we will be able to come back and weigh that and make a conclusion about what we've done with the lab. Here's the precipitate immediately following the lab, so it will sit here to dry for as long as it needs to, and here's our label since it will be left unattended. Here's the fully dried end product. After conducting 4 different weighing tests, I've concluded that the filter paper and the precipitate both together weigh 3.4 grams. So now I will add that to my lab notes and begin the analysis. Here we have the equation for the reaction, and this shows my process for finding the theoretical yield and the percent yield. So the first thing to do was to take the amount of calcium chloride and sodium carbonate that we used in the lab, which was for me 2.1 grams of calcium chloride and 2.5 grams of sodium carbonate, and use that to calculate the theoretical yield using both substances. Since the theoretical yield from the calcium chloride was only 1.89 grams, which was less than what we got from the sodium carbonate, that means that that's our limiting reactant. So our theoretical yield was 1.89 grams of calcium carbonate. Now in the lab we ended up with 1.3 grams of actual product. So dividing our actual yield by our theoretical yield, I found that we have a percent yield of 68%. Now let's switch gears over to our critical thinking prompt for this week. And what we're going to be discussing is how this type of chemistry is used at water treatment plants to soften hard water. I found this really good article from the Chemical Education Digital Library by Vitz et al., and it talks about exactly everything that we would want to know for this prompt about how precipitation reactions are used in wastewater treatment. The most important thing to note here is that it's talking about what it looks like when we have a precipitation reaction. It also briefly goes over the solubilities of different compounds. That's just some good background information about why it works the way that it works and why they use this process. So mainly they're looking to remove alkaline earth metals, and this is what we call water softening. So they use 2 primary chemicals to do this. They use lime and soda ash. They also remove some transition elements, and they use lime for this quite a bit. So it's interesting because they can create these reactions, and when they have these reactions, it makes it very easy for the undesirable elements and metals to be easily filtered out of the water. And basically, that's the filtration process. It's exactly like what we did in our lab this week. And finally, for our self-reflection this week, we were tasked with looking at some of the skills and awareness that we've had throughout the course as we've done labs and we've gotten more and more practice, and reflect on the confidence levels that we felt with a couple of different topics. For me, I picked confidence to perform lab experiments with proper safety measures, perform lab procedures, apply stoichiometry to calculate masses in a chemical reaction, perform filtration, and predict experiment results based on module concepts. And in this graph, we were tasked to have two lines, one line representing our confidence level before the labs and a second line showing our confidence level after the labs. So for me personally, with the confidence to perform the lab experiments safely, I had done labs before, so I wasn't completely unconfident, but it had been a while, so my confidence was pretty low. But after getting back into the swing of things, my confidence has gotten a bit high, so we've gone from 3 to 7. For performing the lab procedures, very similarly, I started kind of at a mid-range with 4, and now I'm about at a 6. Applying stoichiometry to calculate masses. This was something that I hadn't done in a really long time. It's been a couple of years since I took my chemistry class, so I was a little rusty. I went low there with a 2. But now that I've had some refreshers, I've watched some really good background videos, and then of course the practice during the labs, I feel a lot better about this process, and I'm now at a 7. For performing filtration, I'm kind of familiar with the idea, so I started out at a 4, but now that I've done it and I've actually worked with the process, I feel really confident about my ability to perform that sort of experiment, so I put it at an 8. And then finally, predicting experiment results based on module concepts. So I started off really shaky there because, as I said, it had been a while since I worked with any of these concepts. So looking at what we're looking at for the week and then being able to predict what may or may not be the outcome of an experiment, I started out really unconfident about that, but now I feel a lot more sure of myself, and I've ended up at a 7. And that concludes my post-lab for the Module 4 lab precipitation reactions. Thank you so much for your time and your attention, and please let me know if you have any questions, comments, or concerns. Thank you.